Today, we're going to be taking a look at our first data analytics portfolio project here on the channel. I couldn't be more excited because it deals with my favorite sport, a big passion of mine, baseball. So what essentially we're going to be doing today is we're going to be grabbing data online. There's two different websites I'm going to be pulling data from. We have Baseball Savant, and then we also have Baseball Reference. I use Baseball Reference all the time. Savant, I believe, is data supplied directly from the MLB. Regardless, we're going to download these spreadsheets. We're going to edit some of the different columns, make sure that the spreadsheets are working properly, import those into SQL, and then we're going to run some queries and grab some data. Now, what specifically we're going to be taking a look at? Well, I grew up in the Tampa Bay region, and my team growing up was the Tampa Bay Rays. They're known to have one of the best pitching departments. We're going to be taking a look at some of the data for their pitchers. More specifically, we're going to be taking a look at the last pitch in a pitching sequence when there's action that is taken. For example, action could be a player hits a double or a home run, or a pitcher gets a strikeout or walks the batter, the last pitch to that batter specifically. And then we're also going to be taking a look at some of the stats for the specific pitchers as well. There's some aggregate stats on Baseball Reference, and we're going to do some joins. We're going to do quite a few queries. In fact, I think we're probably close to 20 or so queries that we're going to be taking a look at in SQL Server Management Studio. We have a lot to go over, so let's start downloading the data online. Oh, and real quick, if you guys are new to the channel or aren't subscribed, please subscribe. This video is going to take well over 10 hours to produce, everything from doing the editing, between building the project and teaching you guys along the way. I'm going to be doing a lot more of these projects here, and I upload almost every single day on the channel, mostly SQL and Python right now, but we will be expanding in the future. All right, let's start solving this. So to grab this data for Rays pitchers, we're first taking a look at Baseball Savant. This is data that's provided specifically from the MLB. Player type, make sure that pitcher is selected over here. Then we go to team, make sure you select the Tampa Bay Rays. Flags over here, you're going to want to click over and choose is last pitch. So that way we have the data on that side of things. Group by player name. And then we need to figure out the games that are played. So for the 2022 season, April 8th was the first day that the Tampa Bay Rays played. So we're going to go over here and select that. And then we have that over there. And then we're just going to copy that format over here. I'm using a website called Baseball Almanac. It's going to show specifically the Rays outcomes for specific days. And then if I scroll down all the way over here, October 5th is the last game. So what I can just do is instead of 4-8, I can just do 10 and 5 like that. And also for season over here, make sure you select 2022. And then I'm going to click search. So this should take a second. Then we're going to go down below and grab all the stats. So here's all the Tampa Bay Rays pitchers for that season. So Corey Kluber threw the most final pitches. Then we had Shane McClanahan, and it has everything down over here to Yu Chang, who pitched 11 final pitches for the Rays. Now to download this data, all you have to do is go over here to the right. It says download data as CSV file. And then we're going to click that. And again, feel free to choose whatever team that you want. Since the Rays are my team, I'm going to go choose the Tampa Bay Rays and run the data on that side of things. So now this CSV has downloaded, and let's open this up. And you guys can see how this works. And I'm just going to format this in autofit column width. Here's how this table is outputted. So we have a pitch type over here. So this will tell you what was thrown. I think this is slider SL, and then we have a changeup cutter, and there's a bunch of different these over here. And maybe one of the things we're going to do is figure out specifically what pitch type was thrown the most as kind of like as a final out, or like was given up as home runs or doubles, different things like that, which would be kind of cool to specifically see. Then we have the release speed. So that's how fast the baseball was thrown. So you can see like 89.3, 90, 93.9. So we could also see like maximum and minimum within this data set once we import this into SQL. Position, X, and also Z, the player name. These IDs link up to specific players. They're unique. So each pitcher will only have one ID. So there's a few different players that have the same first and last name in the league. So that's why we need to have this unique ID, and especially over time as well. A description, specifically what happened with that. So for example, this first one over here was hit, and then called strike, which leads to an event of a strikeout. So again, something that we could take a look at, like what happens when there's strikeouts, what's the average speed of a strikeout? What's the average pitch? A lot of data that we can dive into. These columns are blank, unfortunately, so there's no data in here. So like if we're cleaning up this data right now, we could just delete these. We don't really need that. So I'm just going to delete those. Zone, I think that's part of the baseball diamond. I don't know what those zones are. So maybe I want to look up these zones. So I'm just going to look up over here, baseball zones. And then we'll just put over here like baseball savant and see if we can find some more information on it. So we'll just do images first. And I'm not seeing, well, let's see. So we have like 31, 32, 33. So maybe it's the inside zone of a, or is it this over here? No, I think zones we're talking about over here is possibly this. Let's take a look. So the data wise, we have 14. So let's take a look, right? 14 singles on a ground ball. So 14 could be right here. I mean, I think that's where we're going to be taking a look at for zones. So you can see like a lot of single digits, which would be in this inner zone, the heart of the, I'm thinking that's what it is, because you don't see anything like super, super high. I mean, you won't really see many of these 30s or 20s because it's kind of outside of the specific pitching zone. And you don't see a lot of those. So I'm thinking it's that. So I'm just going to keep a mental note. And again, that's data that we could filter on. We could look at how much was in the first 9. Then we can take a look at the outside, shadow, chase, and also waste area and see like if any of those were specifically hit. And then we have a description, which gives us even more information on that side of things, like what happened. We already have events and description, but this gives you a lot more. So you can see Rafael Devers. He has that batter ID, 6'4", 240. He's a better player for the Boston Red Sox. Then we have a game type over here, which is, this one says R. And then let's see if there's anything else. It just says R all across the board. So I'm not too sure what a game type is, which is kind of weird. Then we have stand, P throws, which I assume is pitcher. So pitcher is a lefty or a righty. There's like one player that could do both, but I don't think he made the major leagues. Then you can see home team, away team. So again, something that we could take a look at. Is there a big difference between this data when the Tampa Bay Rays are home or away? Type, I'm not too sure what this is. Since I don't know what game type is, I'm just going to delete that. Stand, maybe that's how the batter is in the box. So let's take a look at this stuff again. So we have a stand of R for Xander Bogaerts. Don't kill me, guys, but I'm not too sure what way Xander Bogaerts bats. Xander Bogaerts, is he a righty or lefty? And we could just grab that from Baseball Reference. So you can see he bats right. Okay, so let's take a look also. Rafael Devers. So we put Devers in here. You can see Devers bats left. And what is in this box? We have L on here for stand. So far those both line up. And let's just check Enrique Hernandez. So Enrique Hernandez. Oh, misspelled that. So Enrique bats right. Let's see if that's over here. So right, and we'll just check one more. Abraham Almonte. I think that's how you pronounce it. And it says he bats both lefty and righty. So he's a switch hitter. So I guess he was standing right that time. And then Reese McGuire, we'll check that one too. Just be 100% sure. And I think that's it right there. And bats left. That's left, we're good, right? And it's left. So I'm just going to say, I'm going to rename this one, which I don't know why it's not letting me. There we go. just lagged for a second. I'm just going to rename this one batter position, like that. And I'm going to rename P throws as pitcher position. I just kind of like that a little bit better. Not letting me write that there. Try it again. Pitcher position, like that. I just, so that way I know righty or lefty. Otherwise I'd be a little confused. I do like the home and away team. So type, we have X and then we have S. So not sure what's going on over there. And then we have B as well. We don't need game year. I'm going to just delete this right now because we're only going to be taking a look at 2022. But I'm trying to see what this type is, right? So X, S, X, 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 X. I don't know specifically. I don't know what that's asking. Let's see what happened over here, right? So we can take a look. Xander singles on a thing. So X he got on base. Okay, so let's see if our thing, Rafael grounds out, but that has an X. I don't know what that type is. If you guys know, let me know. Otherwise, I'm just going to delete this one. I don't want to be confused. Hit location. So earlier I was talking about how, where was that at? Zone was possibly location. But it would have to be this, right? So hit location. And this, what I'm thinking is like the position in the diamond. So if you don't know how a baseball diamond works, let's check this out. We have a baseball diamond and then positions. So here's how this works. So like if it got hit back to the pitcher, it'd be 1. And then the pitcher throws it to first base. You have like a 1-3 play. So let's see if that lines up. So hit location 5. So 5 would be third base. And let's see what happens. And it says baseball type over here, ground ball. And then this one's a 3. So 3 is going to be first base. So we're looking at third base and then first base on these two. So let's see. Singles on a ground ball to third base. That first base over here, right? And then strikes, which has nothing over here on that side of things because it struck out. And then hit location is a 2, which is our catcher. You don't technically hit over there. I don't know why it says 2, called out on strikes, but then you have other ones that are blank. So we have a hit location here. It's a fly ball, but that's blank. Oh, because he homers, right? So if we hit the baseball out of the ballpark, right, we're not going to have a hit location. So that all makes sense. And this is stuff that we could really dive into if we wanted to. Type over here, again, 2, strikeout, so that makes sense why that's not there. Fly ball, makes sense, home run, right? Strikeout, I assume, all these 2s are always going to be strikeouts. Then we have some 9s, line drives. So this is great information, right? I wish 2s were filled out with strikeout, essentially. And then there's some that are both blank, like over here. So we're gonna have to take a look at that. We might have to clean up that data. Let's take a look. It's tough, right? Let's take a look at why this one is double blank. So over here, he walked, right? So that makes sense, right? Hit location, there's none of that. And it says BB type. So maybe we wanna add in more information over here just to clean this up. So like if it's a 2, we could say it's a strikeout. And then I don't know if all of these are going to be walks. Let's take a look. Well, they aren't because look, this says it's a fly ball, but there's no hit location. So that's kind of, well, again, home run. Should have known that one. But these are both blank. Let's take a look. Walks. So maybe we want to filter this out, right? And just say that 2s are going to be all strikeouts. So you can always manipulate your data sources if you want to make them a little bit easier. So all I'm going to do over here is sort and filter. And I'm just going to filter on these 2s so far, right? And besides pop-up, right, which I should probably filter out on this side of things too. So like ground ball, I would assume would be a bunt on that side of things. And we'll take a look at that too. But all these should be strikes, right? Strikeout, 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 right? Strikes out, all strikeouts, which is great. So I think we should update that and say this is a strikeout, just so we don't get lost if we're going to be taking a look at that over here. And, you know, we could make changes within our SQL if we wanted to output this type of stuff, but I'd rather just, again, clean up the data now and be done with it. So I'm just going to look at this ground ball section now. And I think these are going to be all bunts. I would rather just mention these are bunts instead. So grounds out softly, catcher, the first base, grounds, bunts. Okay, so it could be, so like sometimes you have, if a batter hits the baseball weird, it doesn't always have to go into the infield or outfield. It might be like a short, it's called a dribbler in baseball. So I guess it's fine keeping it like this because you could have both dribblers and bunts classified together where it's a hit location 2 and type like that. Just kind of a weird case. I'm just going to select all again. And hit location, I'm just going to select all again. So we do have these blank ones over here. I'm going to keep those blank just because it does fit that criteria. And then these ones over here, I think that's what we're going to take a look at now. If the BB type is blank like this and hit location is blank, then we're going to be looking at a walk. So I want to filter those out now. So the way I do that one is go over here and just show blanks. And then I want to filter out fly balls and also line drives. And then all these should be walks. And you can see 3-1. Well, except for these ones over here where we have a 1. So 1 is going to be hit by pitch or a 2. But everything else at 3 is going to be a walk 90% of the time. So maybe we don't update that. It's tough, right? Because... And maybe we'll have to just do that in SQL because even with like a 3-1 count or a 3-2 count, a batter technically could be hit by pitch. And we're going to be messing up with that data now. So I'm not going to mess with it. So we'll just keep it like this and I'll select all again and we'll keep going through. But all this information is good so far, right? I like it. Okay. Then I'm just going to remove this sort and filter right now because I can read this. So we have balls and strikes. Again, we could take a look at outcomes based off of specific situation. We have PF X_X, Z, plate X. I don't know what those stand for, plate Z. Maybe that's where the batter is standing for plate. I'm gonna look that up. So let's just put that here. Baseball, Savant. See if we can find any information. So here's documentation, right? And always important to take a look at. So this is horizontal movement in feet from the catcher's perspective. Vertical movement in feet from the catcher's perspective. I don't know if I'm going to be going that granular with this data set. Maybe in the future we could do something like that. I just don't know what we're doing with it. So I'm just going to delete this on now. This will tell you on third, on second, on first, if someone is on base. So again, some data that we could take a look at. You know, is if someone's on base, what's the percentage that, you know, pitcher gives up a home run? We could take a look at this specifically. And I think that's kind of cool. So we're going to keep those out over here. Outs went up. Again, more data. So you have 0, 1, or 2. 3 outs in a baseball inning. Okay. Then we have the inning on this side of things. So inning 5, inning 4, 3, right? Tells you when it is. So bottom, and then they should have top, I think, on this side of things. So you have top and bottom inning wise. I don't think we'll be needing that specifically, so I'm just going to delete that. I do think we could use innings and outs, but I don't really care too much about that. HCX, I don't know what that is. So again, go to their documentation, see if we need that. Hit coordinate of the batted baseball. So that's kind of cool, but again, you'd have to map it out, the X and Y planes. And I mean, we could, it's tough. Like we could definitely use this. I think it's a little bit outside the scope of this video for the hit coordinate. So again, maybe something in the future, but I'm not gonna use that here. TFS, I don't know what those are. So I'm gonna delete that. fielder. So this is who's catching it. We'd have to link this out to a specific fielder ID to know the name, unless it's in that description over here, which some of them are. I would assume not all of them are. But we don't need that. Umpire is going to be blank, so don't need that. This is blank as well. Like this. And again, we're trying to clean this up because I would rather have a lot smaller of a table within the database. So far we have pitcher type, right? Game date, release speed, position on here. And I don't know. We're going to keep these for now. I'm like not 100% sure we're going to delete those or not. And like all those, don't know what these are over here. So let's say like YX0. Look at that. So velocity of the pitch in feet per second. Okay, I do like the velocity pitch in feet per second in X dimension. Oh, so some really, really advanced stuff. I think that's going to be a little bit outside the scope of this video, but I think it'd be kind of fun to do. Not going to lie, but we're going to try to keep this simple. SZ top, let's see what that is on here. Top of the batter strike zone set by the operator when the ball is halfway to the plate. Use that. Okay. Hit distance in SC. Let's see that. That doesn't even show up in here, right? So I don't know. Launch speed and launch angle. So that's more the batters. I think it would be kind of cool to see. We could definitely do some analysis on this. Like what's the most common type of pitches when there's a specific launch speed and things like that. So maybe we're going to keep that on here. So we'll keep this for now. Effective speed. Spin rate super effective in baseball. It's actually matters quite a bit. So let's take a look on here. Effective speed, derived speed based on the extension of the pitcher's release. Interesting. So we have an effective speed, and then what was the other speed that we had over here? Release speed. So they're a little bit different. It's like 89 versus 89.3, 89.9 versus 89.3. I'm just going to honestly hold on to release speed for now. Maybe we could, I don't know. Maybe we could use this data a little bit, but I know like if we're going super granular, we could. I'm going to delete it for now. There's a lot that we could take a look at. Spin rate, I 100% want to take a look at. A release extension, I want to take a look at. Then we have game PK. So I think that's like the primary key of each game, like what happened in that game. So let's just see. Unique ID for the game, right? So if we're going to link over to a game table, there's that data out there. We could just grab all of that. We're not going to be doing that in this project, so I'm going to delete that. We already have the pitcher over here. I don't care about the fielders on there, so we will that. I'm going to remove that over here. Estimated batting average using speed angle, WABA. So I'm not going to use these on here. Grab that. Batted baseball and play value, right? ISO value. These are some just advanced statistics. We could get, there's so much you could talk about with baseball side of things. Launch speed angle, at bat number, pitch number. So like that could be interesting. Does this go all the way up though? It doesn't. So I was looking at like pitch number, like, so if a starter is pitching a game, like pitch 80, like what's happening over there, but I don't think that's that. I'm just going to double check. Maybe it's in the at bat, the pitch number. And I think that would make more sense because like you have 8 over here, 4, 5, 1, 8. Like it just seems like what pitch number, like in the sequence it would be. Total pitches of plate appearance. So that makes sense. That's over here. Pitch name. Thought we had that sinker. So I said that was a slider earlier. So that's actually SI, capital I, not lowercase. I actually like this pitch name over here better than that one. And we can always rearrange these columns too. But we don't need that pitch type over here anymore. I'm just going to say that. And where was that over here? I'm just going to delete this. Then we have home score, away score. you could take a look at like what happens in a losing game, what's more likely to happen, like pitching wise. You want it to be that granular. And I guess we'll keep that for now. So we'll keep that home away. Bat score, post away score, post that. I don't care about that. Fielding alignment. So that's changed a bit because shifts are now banned in baseball. So I wonder if like strategic would be like a shift or something like that. Well, you actually have it here, infield shift. So could get some data on that, but it's going to be a little bit outdated now because it's gone in from baseball. They banned that. Outfield alignment as well. So this is, so I misspoke. This is infield. This is outfield. If we still had shifts in baseball, important. Spin axis, delta home win expectancy, delta run expected. We're going to delete those. Okay, a lot of data here still. And geez, lots and lots of information on this side of things. So I'm just gonna insert this over here. So we have game date, sinker, release speed, release position X, Z. We're gonna take a look at that. I don't know why there's some negatives in here. So I was like 50-50 on them. I don't think we're gonna need them in this video. So I thought about breaking up this data into multiple tables, but I think I'm gonna honestly keep it over here like this. Now, could these columns be realigned and make it a little bit nicer? Sure. But honestly, I'm going to keep it like this for now. I am going to make a second table though. So I'm going to grab data from baseball reference now. So all you have to do for like baseball reference, I'm just going to Google search this over here. So what I could just do is baseball reference, and we'll put Tampa Bay Rays 2022 stats. And you'll have all the statistics on the Rays over here, right? So like last year they were 87 or 86 and 76, right? And they lost the AL wildcard to Cleveland. That doesn't matter to me. I actually just want to grab the stats over here with team pitching. And the thing is, now we can find data specifically on the pitcher. So what's kind of cool is we can find data and break it down between starting pitchers or relief pitchers. So like, you can see Corey Kluber is a starting pitcher, so he should have specifically more pitches in this table than a relief pitcher. So we can definitely test that, but also we can take a look at stats like WHIP, which is walks, hits, innings pitched, and kind of analyze that specifically. Like, do people with lower WHIP, do they give up more home runs or less home runs? It should be less home runs, hypothetically, but we can kind of start running that data with this over here, which was kind of lacking on this side of things. Just because this was pitch data, but now we can see how a pitcher did across the season. So all I'm going to do is go to share and export, and I'm going to say get as Excel workbook. So let's click that. You can see it downloads over here, and this populates. So it's kind of cool, right? I still trust it. Yes. And it'll take a second. So we have all this information over here. But we need to figure out a way to link these tables together. So, and also I should mention, let's click enable editing. I don't care about these last rows over here. Team totals, that's going to mess our things up. So I'm going to delete that. And also I'm going to actually update this over here because really we don't need RK, which would be like ranking, I would assume. What we do need though, and if we go back over here to the Savant data, to link these over, we're going to link on our pitcher numbers. So we need to figure out what pitcher number is associated with all these in this data source. So I'm just going to copy this pitching number over here like this. And bold this on that side of things. And we're going to delete all of that. We just need to figure out what these guys are. So there's a few different ways that you could do that. And also I'm going to remove that star at the end of this name. We're going to clean up some data, right? We don't need those specific stars. So let's get rid of that. this side of things. And there's probably a way easier way to do this than that, but there's honestly only what, 40 in total. So it doesn't bother me as much. Other thing that is kind of annoying with this data set is we don't really have a lot of relief pitcher or starting pitcher for all these other pitchers. Like Tyler Glasnow is a starting pitcher, but you can see over here, like I believe he was hurt for most of the season and just came in towards the very end. So just like in this instance, I'm just going to double check real quick by like innings pitched. There's a lot of innings pitched. You either assume like they're a highly used relief pitcher or a starter. But you can see like 166 over here. It's tough to say, like, should I just put relief pitcher for all these guys over here or what I'm going to specifically do? We'll figure that out in a second. Let's grab these specifically numbers for everyone. So I'm just going to put this on my second screen, all this data over here, and we're just going to start mapping this. So what I'm going to do specifically is I'm going to copy these two columns, player name and pitcher. So watch this. So I'll put this over here like that. And then what I'm going to go over here is to data, and then I'm going to remove duplicates. Okay. And 40 unique values remain. So I just want to double check this works correctly. So let's look for Chris Mazza. Let's see if he's 607391. So always check your data too. Chris Mazza 607391. Good. We'll check like two more just to make sure. Whistler Matt, he's 605358. Next, Whistler Matt 605538. So we'll check one more. We'll check. We're here, Ryan Yarborough. So we'll just put that over here. Next, 642232, 642. So like it lines up. So great. So what I'm going to do is specifically, I'm going to put these in ABC order. So home, sort, filter, A to Z, expand. So these are in ABC order now. We have 40 over here. And then I'm going to go over here. And I'm also going to label these in ABC order. So sort, filter, A to Z, right? So Andrew should be first. Did we have an Andrew on here? We do not have an Andrew. So we might have to do some updates to this data, but I'm just going to copy all of these like this. And I'm going to just paste them on here and we'll figure it out from there. All right, so okay, so some of the reasons why this data is not working correctly also, I just realized is this is first name, last name. This is last name, first name. Pretty annoying, right? So a few different ways we could do that. I'm just going to delete this over here. I'm going to go back over here. And I believe I can just copy the data specifically with the comma on the right or separate it. I think there's a way. So I'm just going to click insert over here and I'm just going to double check this. I'm going to Google search this, right? Spread out data, 2 columns, comma, like this, right? And so convert wizard. Okay, that makes sense on that side. Data, text to columns, and then we'll just insert another one, right? Data over here, and let's go grab it, text to columns. Next, next, finish. Did not work. So let's grab all that again. Text to columns. All right, why did that not work? So text to columns, let's try this again. Next. Oh, that's why. Because I put tab instead of comma. Okay, so next, right? Finish. Great, now we have Adam, Jason. So we really care about this over here, the first name and then last name. But it's filtered by this, so we're gonna say last name. And on here, we'll put first name. And now we can do A to Z. Okay, so great. Now we have all this data. I'm gonna copy this And we're going to try this again. Should work. Should work on this side. So let's now throw this in here. And Andrew is first, right? Brett Phillips, Yu Chang, just check another one, Luis Patino, Dustin. Great, all this lines up. So now all you have to do is grab this pitcher ID on this side of things, Control C, throw that over here, and we're going to delete that. So now this looks a lot better. We have pitcher, which I'm going to rename this as like pitcher ID. That, and then it kind of sucks. Most of these positions aren't filled out like this. Really does suck, because we could have some great analysis on this. But actually I found a way we could do that. So what we could do is game started. So game started wise, like if you're a starter, you're going to have a lot of these. If you're a relief pitcher, you're going to have 0. So automatically anyone with 0 game started, we can put as the RP position because they did not start a game. So that already cleans up a lot of our data. And then now we're down to this on this side of things. But the thing is, it's interesting in baseball is you do have a new position called like an opener. It's not really a starting pitcher. So some of these guys could technically be openers. And then some other stuff we could do too is if anyone has a save, they're going to be automatically a relief pitcher because starters don't get saves. So anyone over here, so you can see 1 or above, these should all be relief pitchers. So we'll copy that over here, right? So that's already on that side of things. I think there should be a hold category. Let's see if there is. Innings pitched, hit by pitch. Don't see a holds category, unless I'm just not paying attention to it. No, I don't see a holds category on here. So, but we're already down to a lot less. Like we have what, not much on that side of things. So what we could take a look at now is innings pitched, and we'll have to estimate it. And I'm just going to filter by blanks, sort and filter by blanks, put that on here. So this is what we're down to on this side of things. So innings pitched wise, I mean, these aren't even full games. Like everything on here is less than 7. I know Glasnow is technically a starter, but he has been hurt. So I think that's why he only had that, or he got hurt extremely early in the season. So I'm putting Glasnow as a starting pitcher just because I know that specifically. Ryan Yarbrough is an interesting case. If I remember correctly, he's an opener, which is technically a relief pitcher, but he had 80 innings on here. Everyone else didn't really have much. Shane Baz, he's also a starting pitcher for sure on that side of things. I'm just going to check with Ryan Yarbrough, make sure he's still a starter or reliever or what he is. Just see on here. We're going to go to MLB.com. Oh, and also make this pretty easy. You could take a look at games and games started. So your games and games started should be about the same if you're a starter. If not, you're going to be a relief pitcher. So like Baz, you can see 6-6, right? Starter. Luis Patino, starter pitcher, right? 6-6 on here. Glasnow, right? So these are the same. If it's different, you're going to be most likely a relief pitcher. This guy's interesting because he has 1 and 1. So I don't know for sure. But everyone else I'm going to put like his RP. And then we'll just look up this guy. So 10 and 3, right? Relief pitcher. 21 and 3. Games over here. Game started 1 and 2. This also has game started 1. This is 1 over here. And then I don't know who this guy is. So Cooper, sorry. Let's just double check. We'll just put over here. 1-1 games, 0 game started. So he's a relief pitcher too. And we'll just put that over here. And then we should have all this mapped out now. And we now have pitcher ID, position name, and all of this data over here if we wanted to grab it. A lot of stuff. But now this is great. Now let's start naming these. So I'm going to name this as and save as over here. I'm going to save this as a CSV. So just go over here, uc.csv, comma delimited right there. And I'm going to name this as Rays pitching stats.csv. Which is great, right? Saved to this PC. And then over here, I'm going to delete this sheet because I don't need it anymore. Delete. And then I'm going to name this one as file save as, and I'm going to just say last pitch and also Rays, not Ryan, but Rays. And we're just going to put this over here as a CSV. And we're just going to save this under downloads also. And now we have our two tables that we're going to be querying from. So we can now start working on SQL Server Management Studio. Under databases, you can create a new database. I'm just going to do that now. So just go over here, new database. And database name, I'm just going to name this as Rays pitching, like that. If I can spell it correctly, right? Rays pitching. We're going to click OK. And this has now been created. Okay, so now that Rays pitching is created, we're just going to go over here, right click, and then we're going to go over here to tasks. And then we're going to import flat file. We're going to go through this wizard. So let's grab the first one over here. I'm just going to go to downloads, last pitch Rays, DBO, and can't open it because it's in still use. So I got to close these out over here. Make sure you close those out. I'm going to close that out too. Now let's try it. Okay, it is working. You can see pitch name, game date, and has all this data over here, which we cleaned up. I'm going to click next. And we have all this information on this side of things, which is great. So allow nulls. So let's make sure all these data types make sense. So pitch name, we have a varchar. Makes sense. Game date is a date. Release speed is float. Okay. Player name, varchar as well. Batter int, pitcher is an int. And again, those are not names. Those are the integers associated with it. Events, that's all written out. Description. That might mean more. I'm just going to put varchar max on that one. Zone is a tiny int. I might make that just as an int. General. Description. Oh, so that's what. Oh, DES. I don't remember if it's description or DES. I think it might have been this one that was 300. Either way, it doesn't matter too much. I'm going to put varchar max there. Batter position. Pitcher position. Home away team. Hit location. Type. I don't even remember all these, to be honest with you, but a lot of these make sense. Spin rate. So spin rate, I think it was a full number. And that goes up to 3,000-ish. I'll just make this as int. Launch angle. Was launch angle... We might want to make a launch angle a float. I don't remember if there's decimal in that or not. Speed there is. Extension, float. Pitch number, int, that's fine. Home score, int. I think it's fine there. Just don't want to have anything mess up. And we got an error. What's our error? Release spin rate does not allow a null value. So let's go back over here. I guess we don't have spin rate on some of these. So we'll have to allow null values on that side of things. I'll take a look, a little bit data cleaning a little bit later. And we got an error again. Column release extension does not allow. So it looks like some of this data wasn't populated. I'm just going to allow nulls on these so that we can throw them in here. I mean, there should always be a score, but and we could always just drop rows and stuff like that. And it's been put in here. Success. Awesome. Let's add in our other one over here. So same exact thing. Once again, go to tasks, import flat file. Let's find the other one. And Rays pitching stats. Throw that in over here. All the data. Okay, looks good. Great. pitcher ID is an int, position, varchar, blah, 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 name, varchar, float. Okay, that worked too. And if we open up our Rays pitching over here, tables, you're going to see that there's nothing. Let's refresh these over here. Over here to tables. And we have both of these, right? And great. Now we can start running stuff. So if I wanted to, I could just do a select star from, and I'll just put Rays pitching dot DBO dot, and then I'll put last pitch Rays. Let's run that. Make sure it populates. All of this populates over here. And again, you can see that we do have null values, and it makes sense why we have null values. Launch speed, if you struck out, there's gonna be nothing there. Okay. And then Rays pitching stats table. So I'm just gonna select star over here too. And just put over here, Rays pitching stats. Boom, all of this is populating. And we're good to start running analysis. Okay, so here's the questions that I want to ask throughout the data sets. So first question is we're going to be taking a look at average pitches per at bat. And we have A through F. Then we have some last pitch analysis, home run analysis, and then we're going to be taking a look at some data based off of Shane McClanahan, one of the best pitchers on the Tampa Bay Rays right now. And there's multiple parts of every single question, varying in difficulty. Some of these are going to be quite difficult to answer. Some of these are going to be a piece of cake. Now, I'm going to supply both this file right here and also the final code in the GitHub link down below in the description. So let's start answering these questions. So first question over here. So what I'm looking for first is the average pitches per at bat. Now this one is going to be actually quite easy. So we do actually have that column, and this is going to be in last pitch Rays. So if we go over last pitch Rays and we scroll over here, we have pitch number, and you can see with 8, 4, 5, 1, 8, 1. So all we have to do is pretty much find the average on that. So very, very basic query with that. So just select, and you're going to put average like this. And then you're going to put over here pitch underscore number, and then from, and we're going to put last pitch Rays. And if we run this, you can see the average is 3. We don't have a name on this, so I'm going to say average num of pitches per at bat, something like that. And we could go more granular if we wanted to. Let's say, for example, you wanted to see, we're at around 3 it lies. So just do 1.0 times it, and you can see 3.83. So, okay, closer to 4 than down at 3. We take a look at this next example over here. We want to see the average pitches per at bat for home versus away. So we have 2 columns for that. We have home team over here, and we have away team. Now, if Tampa Bay is in the home team, they're a home game. If they're in the away team, they're a away game. So you can see these are aways. And then if we scroll down, you are home. So we can do this in a union, and I want to do that for this example. So pretty easy on that side of things. So we can have this query used almost again. So select, well, average 1.0 is that, right? And then we're going to say home is, and we're going to say type of game like this. And then we're going to say where home team equals Tampa Bay. Now this will give me the data specifically for these home games. And if we run that over here, they get an error. And that's because I just need a comma on that side of things. And now you can see 3.85 for home. Okay. And I'm actually going to rearrange these because I like this a little bit better on that side of things. I'll put my comma here. Now, if you run this, I just rearranged them. I like home like that. And then all we got to do is union this. So union, great. And do the same thing, select, and then we're going to put away. And then instead of home team, we're going to say away team like that. And now if we run this, you can see home 3.85, away 3.8. So pitchers are slightly more efficient at away games. And I don't like it all caps, so I'm just going to put like that. Slightly more efficient on that side of things than those home games. But again, super easy. Just thought union would be nice on that side of things. Okay, so this time we're going to be taking a look at average pitches per at bat, lefty versus righty. So technically you could just union this again, but this time I just wanted to show a case statement. So kind of similar in that sense. I'm just going to copy the statement over here. And instead of average, start writing this out. So, okay, for part C, average pitches per at bat, lefty versus righty. So honestly, this is pretty easy. I could just copy pretty much this and paste it for a union, but we want a case statement this time. So I'm just going to copy this first part and we're going to build off of that. So just throw this over here. I don't need that. I need to fix the select. So that's working. So I like this average here, but this time we're going to say case when, and now we have to look for when a batter is lefty or righty. We don't need this home team also. So if we go back into last pitch, we're going to take a look at batter position. Because I think average pitches per at bat, lefty versus righty. Yep. So case when batter position equals L, then 1.0, and I'm going to say lefty at bats. I also need to put an end over here. And then we can literally just copy and paste this and make it for the righty. So instead of an L, just put an R over there. And we'll just put righty at bats. Remove this comma because we have the error from that from. And you can see lefty 3.86 and righty 3.813. So also it kind of shows you the difference between unions. So if you look at the union, when we compile this data, right, you have them down like this versus the case statement, they're going to be columns. So rows versus columns. Sometimes you see those on type of leak code questions. So you kind of have an idea where to approach that question. And that's kind of why I wanted to split these up. Really, you could have done the same exact question twice, just both different ways, but not too bad there. And you could also technically switch this stuff if you wanted to by using pivots and unpivots, but that's way more complicated. And for this simple code, just write it like that. Okay, so part D, we're going to take a look at average pitches per at bat, lefty versus righty pitcher, unlike lefty versus righty batter up here, and then each away team. So, and I also want to show a partition by on this example. And let's just think about this. So we're going to just do a select star for now. We'll keep this over here. Right. And I want to have the away team as Tampa because we're not taking a look at home games. So this right here, we have 2,940 rows. Great. Now we need to look at it from what we specifically need to get outputted. So I would like to show the team. So we're going to say home team because we want to show that. We also need to show the pitcher position and whether it's a lefty or righty. So pitcher position. And then now we need to do our partition by. So since we're doing average, so we're going to do average. And then let's grab this again. So 1.0 times pitch number. So throw that in here like that. And we're going to say over. And inside over here, we're going to partition by, and we're taking a look at each team, right? So first we need a partition by this home team, and then we need a partition by this pitcher position like that. And honestly, that should pretty much be it. We're going to get duplicates on this side of things because it's going to show it for each specific row going through. And Really, you could do a group by statement, make this a lot easier, but instead we're doing a partition with this one. So what you need to do is put a distinct like this. And you can see like Baltimore, Lefty, 3.54, Baltimore, Righty, 3.75. It's interesting, like Boston, we have 4.08 versus 3.75. And you can really do some analysis on this side of things, taking a look at teams, like if you're facing them. Sometimes with like National League teams, sample size can be pretty low because you're not playing them all the time in comparison to like a Boston or a Baltimore. You play multiple times throughout a season. But you can see that Baltimore tends to use more pitches against a righty than a lefty, which nowadays for pitchers, they were kind of limited with your pitch counts. So you might want to be a little bit more strategic on that side of things. I'm not saying that's a huge difference for relief pitchers, but for a starting pitcher, it can add up. And just kind of see the differences on these two. Like New York Yankees right here, this is kind of close, 3.8 versus 3.96. Oakland 3.3 versus 3.6. That's pretty big area on that side of things. We have all the way Minnesota lefties, 4.6 pitches, which is a lot compared to a righty, which is 3.73. And Minnesota plays Tampa a decent amount. They're in Central, AL Central, compared to AL East, but that's a big difference between lefties and righties. So kind of cool to see some of that analysis on that side of things. And since we have 36 over here, 18 different teams are represented. Okay, let's take a look at E now. And I think this is where it's going to start getting a little bit more complicated. Like these queries, pretty cake so far. But for E, so we're looking for the top 3 most common pitches for at bat 1 through 10. And the total amounts, and we're just going to be using this last pitch table again. Okay, this is going to be a fun one. So let's think about how we're going to work on this one first. Okay, so right out the bat, we should select, and we should probably do like pitch name, pitch number, and then we should also have a count as well. So let's do a count. We'll have like pitch name in here, because we're taking a look at that specifically over, and then we're going to do a partition by pitch name, right? Because we want to have each of those separate, and also pitch number. That, and we're just going to put from over here. I think this is the start of it, right? All that goes over here, and let's just take a look. Should also put distinct, and then pitch numbers or something like that. Okay, so you can see like pitch name 4 seam fastball 1, 2, 3, 4, 5 goes all the way through 12. But you can see 147, 184, 282, and this analysis over here. So like change-ups, most common is for 3, curveball 4, cutter, most common for 1, and then like a sinker 2. So now we need to we should probably filter out this pitch number because we're saying 1 through 10. So let's just say where pitch number is less than 10. Pitch number, well, less than 11 because we want to show 10 on here. So that should get rid of anything there, which is good. Now we need to filter like where pitch number is less than 3. So what we could do is we can actually make this as a width, and then we could just query it down below. So I'm going to try that. So with, I'll just say this one like total pitch sequence or something like that. I don't know. Once as, and then we can just put this over here like that. Although I recommend that you build it out a little bit cleaner than I do over here. I kind of like that. And now we need to have our select statement. So select, I'm just going to put a star for now from total pitch sequence just to make sure this is working. And it is. Okay. So now we need to think about how we could specifically show the top 3 for each pitch number. So we might have to do this by a rank function. Yeah, I think we're gonna have to do a rank function, and then I think that's gonna be it, because like pitch 1 we have 147 over here. That would show first. Oh, cutter would show first. We have 149. And then sinker 152. So sinker might be first. I think that's what we're gonna have to do. So what I'm just gonna try out first is I'm just gonna put a comma over here and starting out a rank. So we're gonna say rank over, and then partition. Well, yeah, so we're gonna partition by pitch number like that, and then order by, and I think it's pitch numbers like this. I guess it's a little confusing. I'm gonna change just the pitch frequency because it is gonna get a little confusing, actually, now that I'm thinking about it. And we're gonna put this descending. So what I'm trying to do with this statement on here is we're partitioning by a pitch number. So like I want to show the rankings for like pitch number 1, like what shows the highest. So like, and we're going to be ordering by pitch frequency, which is that column. If I run this again, just to show you, as I renamed this, we want to show like what's the highest for each of these pitch numbers. So let's see if this works. Okay, so, and I should name this one as pitch frequency ranking. And I'll run that again. Okay, so I think that worked because we have sinker, which is, you can see now we have pitch number, right? 1, 1, 1, and then this is pitch 2, 3, 4. Yeah. This is working now. Awesome. So you can see like for pitch 1, sinker is actually the most common to get someone out with. 152, then a cutter, and then a 4-seam fastball. And then for pitch number 2, 4-seam fastball is overwhelmingly like 184 over here, sinker 179, then 143. So now we need to do this top 3 on here. So we technically could use another width in here, and you don't have to write width again. All you have to do is kind of like comma, and then I'm just gonna say pitch frequency, see, rank query or something like that, rank query as, and then put all this in here again. And kind of one of my pet peeves, I'm not gonna lie, is putting select stars. I don't like that, except for when I test something quick. So I'm just gonna copy this stuff over here again. So pitch name, right? Pitch number, like that, and pitch frequency. So that should all work again. And just to double check, right? We can do a select star from here. And we should get 88 rows. We get 88 rows, and sinker still 152, 4-seam. And now, since we want to do the top 3 most common for 1 through 10, we're going to have to say where is less than 4. And that should solve this query. So if we run this now, 1, 2, 3, 1, 2, 3, and then 10, right? Pitch frequency. 10 doesn't show up that often. 1, 2, 3, and 2 are tied with 3. We didn't really specify what's going to happen in that case. And there's a few different things that you could do. You could do a rank, dense rank, or a row. I just decided to use rank. It doesn't really matter to me too much in this example, but a little bit complicated with this one. It's a doozy. But that was able to get our information over here, and it kind of shows you how the complexity of SQL can be, even when you're just using one specific table, if you really wanted to. And if you guys have an easy way to write this query, let me know. Or any of these queries, to be honest with you, definitely take advantage of that. put down in the comment section if you're able to make these a little bit better, because I definitely want to learn too if you can make these faster or make them a little bit more efficient. That way I can improve my skills, and if you have that knowledge too, rewriting these through. So we have one question left for part 1 of 4. And this is average pitches per at bat with a pitcher of 20 plus innings, order and descending. And we're actually going to be using 2 tables now. So we're going to do our joins, which is nice. And we're going to go from there. So I'm just going to do a select star from our main table over here. I'm just going to copy this code. So select star. And if you remember a little bit earlier, we are going to have to join these on this pitcher over here. So last pitch Rays has pitcher number, which is that. And then Rays pitching stats is, I think, actually called pitcher number. Oh, it's called pitcher ID. We do need to grab that over here. And we need to join this. So what I'm going to do is I'm just going to do inner join because I don't want to show anything else. So we're going to join. We're going to grab this over here. And now we need to label these 2 tables because I am not going to write this out every time. So I'm going to name this one as LPR and I'm going to name this one as RPS. Again, feel free to name them whatever you want, honestly. And we're going to say on RPS.pitcher ID equals LPR.pitcher like this. And let's just make sure this one is working. And 5927, if we scroll all the way over here to the right, all the data for the pitchers. So Josh Fleming, and let's just make sure Josh Fleming is over here. A lot of those, and it's working. So that's really good. So now let's start filtering. I think the easiest thing is to look at innings pitched first. So we're going to put where an innings pitched in here, I believe, is IP. Let's see, wins. Where's innings pitched at? We're going to find it. Oh, it is IP. I was blind. So we're IP, and baseball is weird because you have 3 outs in an inning. So what I'm going to say is greater than or equal to 20. So anything 20 or above will show. And that's specifically for those pitchers. So average pitches per at bat for pitchers with 20 plus innings. This is honestly pretty easy. Now we have to grab the name of the pitcher, and there's 2 ways to grab the name. We have this over here, and then we have another one, which is last name, first name. I'm just honestly going to grab this one because it's cleaner. So that's RPS.name, RPS.name, and then we need to have the pitcher, pitches. So that's pretty much everything we did a little bit earlier. So 1.0 times pitch number, we can just grab that. So I'm going to format this a little bit better. So we have that there. And then say average pitches like that. And then just as average pitches per at bat, 20 plus innings. And then we have to order in descending. So order by, and then average pitches. Well, we're not going to grab average pitches there. We're going to have to grab this over here. So I can actually copy this. Descending. And the only thing that I still need to do is group by, because I'm going to get an error if I don't, because we have aggregate function here and just have a call over here to the name. So need to put over here the group by. And so that's always after your where statement. So group by rps.name. And I think that should be it. So let's run this now. Should get like what, 40 or so pictures. Well, that's 40 if there was no filter for IP. So you can see Calvin is the most inefficient, 4.28. And Andrew, 3.1. Very efficient. Corey Kluber, 3.5. Ralph Garza, 3.39. So just the efficiency of a pitcher, how fast they can get through stuff. And there's not always a correlation with how efficient someone is and how good of a pitcher they are. But some of the best pitchers are like that. If you look in history, like a Greg Maddux, known for his complete games, and barely pitched at all, man. He did a phenomenal job. I know I'm kind of nerding out on baseball right now, but Then you have other pitchers like Nolan Ryan, who I'm named after. Not efficient at all, but he was a beast. A lot of strikeouts and still pitched in a lot of complete games and 7 no-hitters. All right, off that tangent, we're in question 2. So we're taking a look at some last pitch analysis. So a little bit different. This first time we're taking a look at number of pitches. Now we're taking a look at last pitches. And honestly, with this data set, there's so much that you could really explore in here if you really wanted to. So what we're doing is a count of the last pitches thrown in descending order. That's cake, man. I love these. Super cake, right? So select, we're going to do counts. And then first we have to actually grab that column for the pitch name. And it's literally just pitch name. So easy, right? So select pitch name. Thank you for the easy question. Counts. And we're going to say from. And we're going to just grab that. Order by count descending. And I'm just going to say times thrown like that. I know we kind of did some similar stuff with that up over here, but this time we're just taking a look at that last pitch exactly. And I'm going to get an issue because I didn't group by the pitch name. Of course, why would we do that? Simple mistake. There we go. 4-seam fastball, 1428, changeup 973, sinker 889, slider 857. Okay. Question A is solved. Look at B. Count of the different last pitches, fastball or off speed. So probably you're a little confused what that is. So a fastball would be considered like a 4-seam fastball, obviously, and then a cutter, because those are going to be like 95 plus, 92, 93, 94 plus. Most of the time, it's a faster pitch. Changeup is slower. Sinker is going to be slower. Slider, it's going to be a little bit slower. Sweeper for sure. Other, don't know specifically what that is, but we're going to assume it's off speed. EFS 100% knuckle curve, yes. Split finger, yes, and also a slurve. So this is pretty much a way of just showing a case statement on this side of things. So pretty easy. So select, and I'm going to honestly keep a lot of this the same for here with this from. But we're just going to do sum. We're going to say case when pitch name, and we're going to use an in. So this is easier than showing multiple ors. So we're going to say pitch name in 4-seam fastball, so single quotes. And then we're going to do the same thing also with this cutter. We're going to say then 1 else 0 end. And we're going to say this is fast ball. And then now we're going to do off speed. And you know how easy this is? Like, also, I should say how easy it is, and I have a syntax error. Close out your in. Don't do what I did and claim how easy it is and just skip it. But again, you know how easy this is? Just copy this here. And in front of in, we're going to put not in. And we're going to say this is off speed. Because then it'll grab everything else that's over here that is not a 4-seam fastball and that is not a cutter. We have red over there just because we need to put that in here. And if we run 2119 and off speed is 3808. Well, we're going to use this again. Because now we need to do the percentage of the different last pitches being a fastball or off speed. So you would think it'd be hard, but honestly, pretty cake. So copy and paste. So this time, since we're doing percentages, I'm just going to do fastball percent and off speed percent. Now we're going to divide by the count. Since we have no filters down here, count will show everything. So we can do that on both. And since we're doing a percentage, let's just do 100 times that. This. So we're going to 100 times the sum, and that sum's divided by the total, which will be the total count is the sum of both of these. And you could technically do this within a with and make it a lot cleaner, but whatever. And 35 fastball, 64 off speed. And if you look over here, this is expected, right? 2109, 3808. So that makes sense. 35% of the time, the final out is going to be on a fastball. 64 is off speed. And for a way more complicated question, so 2D, top 5 most common last pitches for a relief pitcher versus a starting pitcher. Oh boy. And instead of doing with this time, we're going to do subqueries just to kind of change up the approach. Although my eyes, I love with because it makes things so much easier just from the readability, but we're going to subquery this one. So also what we should probably do is be lazy and go over here, and we're going to copy our code from over here because we already joined these two tables together. Why rewrite it? And just do a select star. So essentially we need to figure out first the most common last pitch, and we need to count these on relief versus starting pitcher. So the way we know relief versus starting pitcher is going to be in this Rays pitching stats. And that's this column that we filled out because it wasn't full, and that's going to be position. So we could do like a count and kind of partition by that side of things, or group by, or whatever we want really. But let's think about this. So we are going to need the POS, right? And that's going to be RPS.POS. We will need that. And obviously we need to have pitch name again. So that's going to be LPR.pitchName. And honestly, so let's select the most common last pitch, relief pitcher versus starting. I think we could just do a group by, make it easy, right? So select, we're going to do a group by. Oops. We could group by both of these, right? And we could also throw both of these over here, and then also counts. I'm thinking that's going to be the easiest approach. Let's see how that shows up. So we have position relief pitcher versus starting pitcher here. You can see 711, 717 for forcing fastball, which would make sense, right? It's the overwhelming one in the table. And changeup is second most popular pitch. But then you can see like relief pitchers really love sinkers, starting pitchers don't. A little bit more subtle differences. I'm sure if we summed up that row also, it would be equal to like the 5809 or whatever it was in this table, but looks correct. So let's label this count as times thrown, something like that. We run this, and now we're going to rank these. So let's do our subquery, and subqueries are pretty easy. So kind of like with, select star from, and this time we're just going to throw all this over here, and I'm just going to name this as A. The lazy way to do it, if you're in your job, don't do A. Name it something actually useful. But since we're in a coding tutorial and I have a lot more questions to go, I'm just going to name it A right now. So, and just to check this works, we had 19 over here. We still got 19. And times thrown is there. So now we need to do a rank. So I'm going to keep, well, instead of keeping that star, I'm just going to put this over here. And I'm getting errors because it needs to be A on those. So select that in here like this, and then times thrown. And now we need to do our rank function. So rank over, and we're going to be partitioning by what? So if top 5 most common last pitches for a relief pitcher versus starting pitcher. So we're going to have to partition by POS. So partition by, and capital A, don't like that. And then we're going to order by times thrown. And we're going to put that in descending. So that way the highest is up here. And this will just show us, I was assuming this says pitch rank. Rank we're getting a lot of errors. Do I not have a comma there? And we are not getting a lot of errors. So grab this now. Okay, so now you can see a relief pitcher versus starting pitcher. 711, 655, 547, 474, 307. So if we're doing the top 5, we just want to show those. And down below for the starting pitchers, we only have 5 pitches. Again, just want to show the top 5. So how we can do that now is, guess what? Another subquery. So, okay. Fun times. Select star from, and let's put all of this in inside. Tab all of that over. And in the most lazy way possible, we're doing this as B. Again, real job, do not do that. But as it's a tutorial, we are going to be doing that. So anyways, what I would recommend is we still do the select star, and I'm going to say where pitch rank, which we have this right over here, b.pitchrank is less than 6 because we want to the top 5. And if we run this, what do you know? We have 10 results in this table, 5 for relief pitchers and 5 for starting pitchers. So really cool. This is how your subquery works. So we're grabbing this first, then second, and then third. And I don't like doing the select stars, but since we're not really doing anything else specifically from this side of things, and we've already filtered down, I think it's fine in this instance. And we're on to part 3, home run analysis. All right, so what pitches have given up the most home runs? So let's go back into our table. We're just going to grab last pitch, and we're going to explore it again. So to find home runs, I know I showed earlier, like hit location would be null. I actually took a look a little bit better at the spreadsheet, and I did find a little bit of an issue with it. And I'm going to just show you guys why. I think this is the spreadsheet over here. So let me just sort, filter, get rid of any filters I have on here. All right, so what I found out, and hit location is over here. So like, let's show events first. So if we go to events, go over here, sort and filter. And this is what happens when you put data. Like, nothing's ever going to be perfect. Let's grab home run. Okay. So you can see hit location is pretty much all blank, which is good. Except someone decided to put 9 over here. I don't know why. Everything else is blank, but we put the number 9 for this home run on here. Maybe I like hit the glove of the fielder and went over. I mean, we could have a Jose Canseco incident, but that kind of ruins it where I was originally looking at that side. And most of these home runs are all going to be fly balls, right? And then we have a line drive a few times. But when I did that analysis, I saw events home runs, and we're at 172. I'm going to assume that's correct and no one messed up on that side of things. So we'll be taking a look at that. Otherwise, if we were going to be taking a look at hit location, we could just show, for example, if I go back over here, I could do like where, and I have a single quote, where hit location is null, and then I could just go over here and show specifically BB type is fly ball, but that's gonna not give us the correct answer. But that's what I wanted to kind of show originally, and I think fly ball is underscore like that. That you could use your nulls, but that's not gonna be the correct answer. We're at 171. One guy kind of messed it up. So just a good reference. And I'm just going to mark this right here. Doesn't work due to bad data. And we're going to show the actual method. Actual way to do it. And it's actually way easier too. I'm just going to put where event equals home run. And completely butchered that at the very end. Do we not have an event column? Thought we did. Events. That's what it was. And now, since this doesn't work, I'm just going to comment that out over here. And since this is what pitches I've given up the most home run, so all I'm going to do is pitch name counts. Let's see, this is home runs. Order by counts descending. Oh boy, we have to do our group by. I'm going to put group by pitch name. And there you go. Four-seam fastball the most, but also kind of makes sense because it's throwing the most. And then we have slider, which is not throwing the second most, but we give up a lot of home runs with sliders and cutters and sinkers and different things like that. Changeup, although it's throwing, I think, second most, if we remember correctly. They give up 15 home runs, but let me just double check because we had that. We had average pitches. Was this in part B or part 2? Count of last pitches, right? So if we run that, I think changeup was 2. You can see changeup was 2, sinker was 3. So changeups, although they're thrown quite a lot, not a lot of home runs. And sinkers over here, slider was number 2. So kind of crazy on that side of things. I think it was, I'm curious where sinker was on that list because we're 889. Sinker, not giving up a ton. Obviously changeup's a better pitch, 15 on that side of things. And like, again, you could do way more analysis than just home runs. Home runs kind of entry level, but changeups, not much home runs on that. Okay. 3B. Show home runs given up by zone and pitch. Show top 5 most common. This sounds like it's going to be a lot of work. It's actually not going to be a lot of work on that side of things. So pretty much what we're going to have to do is select, and we have a column for zone. And just to show you guys what baseball zones were, I showed a little bit earlier, but we're looking specifically, we're in here, the baseball's throwing the most for home runs. So select zone, and we're going to grab pitch name. Copy this from. All right. And then we're going to group by these two as well, or forget. Our events is home runs. Also, we need to copy that over here. And just copy that count for home runs. Select that. And starting to get there. It's not fully done yet, but you can see zone 1, 4, 10. All this data is showing. Cool, right? We need to do our order by. So now we could specifically see what is going on. So we have order by. You can see zone 5 has 13. If we go over here, does that make sense? Zone 5, right down the plate, right down the middle. Pitchers are not supposed to throw a four-seam fastball right down the middle. They do. And then 2, which is probably a little bit higher than 5, which is a really good spot as well. If you think about like where a baseball batter swings, if they're trying to get the elevation, right? 2 right there, it would make sense. And then slider, right? Zone 5 right down the middle. So you're going to see zone 5 quite a lot. And you can see a 6 over here. We don't want to show top 5, but zone 5 takes up 3 to spots of 6. Like theoretically, this data makes sense where it'd be correct. So all we have to do for top 5 is select top 5, and we're done. That's pretty easy. Sounded a lot complicated, but essentially was not. Yeah, let's move on to C. So show home runs for each count type, balls and strikes, and type of pitcher. So that tells me we have to go back over here because our type of pitcher was in here. So let's just grab this and start working with it. So it just says count type and balls and strikes and type of pitcher. So we have that. We have to look for balls and strikes now. So I think it's just literally called balls and strikes. Balls, strikes, great. So we have position, right? We're going to put lpr.balls, lpr.strikes, and we're going to do a count, home runs, and throw all these in the group by. Well, let's put our where events is here. We're just gonna copy these 3 lines, and for our group by, copy all this over here. And it's saying for everything, right? So we could have it specifically like that. Balls, strikes. So 0-0. Starting pitcher is giving up 20 home runs. That's the most common type, it looks like, right? Relief pitcher 0-1. Then 0-0 for relief pitcher. Relief pitcher 1-0, 1-0. And those are never good. But it looks like starting pitchers tend to throw the meatballs and give up home runs like there. You can see 0-2. For starting pitchers, only 1 home run. Pitchers tend to be in control on that side of things. And for relief pitchers, only 4 on that side of things. 3-0, maybe it's a walk. I would have thought 3-0 would have had more home runs, to be honest, because it's kind of a batter count. And yeah, not as much. And I thought 3-2 would be a little bit higher. This is kind of a higher pressure situation. But that kind of surprises me, the 3-1 and also the 3-0. But that's the data, what it is specifically showing us. And 3D, show each pitcher's most common count to give up a home run, minimum 30 innings pitched. So this time, we'll figure out our select in a second. But we need also innings pitched in here. So we're going to put an IP is greater than or equal to than 30 on that side of things. And most common count to give up a home run. All right. So we need to have balls and strikes on here for sure. Also the count. And we also need to have the pitcher name. And we grab the pitcher name in one of these over here. Was it the first one? RPS.name. That's what it was. So, and then let's group by these over here. Let's see what this shows up. So Corey Kluber, man, 1-0 counts. He's given up 6 home runs, and you can see all the way down here, the 76. All right, so now we need to just show the top 1 for each of these guys, the most common counts. So we could use with statements again, and I'm going to say with like home run counts pitchers or something like that. As, throw all this in here. Star from here. But we're going to do that 3. Yeah, I can't do this order by count on here. I'm a dummy. But why is this not working now? Okay, it is working. All right, so now what we could do is have a rank. I'm just going to copy all this over here first. Well, yeah. It doesn't matter. We'll put HCP over here for all of these. So now we're going to have a rank. So rank, and do over, and then we're partitioning by the name. So partition by the name, Also balls and strikes. Balls, strikes, order by home runs, descending, home run rank. Put a comma over here. And let's run this all. No comma there. I copied that over wrong. All right, let's see if this works. Brooks 2, Brooks 1. That is not working correctly. As you can see, like the rank. Well, actually, I messed up. Because we shouldn't be partitioning by all that. We're just going to partition by name. Balls and strikes we will not be. And that's why everything's showing up as 1. We're just looking for the one case for the name. So if we do that, yeah, there we go. So you can see like 0, 0 shows up with 2 home runs. That's home run rank 1, and then 1, 1 has, or 0, 1 has 1 home run, so that's why it's 2 there. Colin has given up 2 home runs for these 3 accounts, so that's why it's 1 there. And then everything else is going to be 4, which a lot of different ones for giving up 1 home run. Klobler, 1. Okay, that makes sense. We're good. So I was a little worried for a second. I'm like, why is this not working? Again, we're going to have to do this one more time. So we're going to say home run count rankings as through all of this over here. And just tab that over. That's our syntax isn't best on this one. But we're going to do one more query over here. So select star from ranks where equals 1. And then name, balls, strikes, home runs, like that. And if you don't want to show home runs ranks, you just have to specify all these specifically from there. So like if we just said this is HT, you wanted to copy all this over here. Again, I know formatting wise, not the best, but put HT, remove the comma here at the end, and this is going to remove that home run row. Shows the ranks, and you can now specifically see the counts most common for the home runs for each of these pitchers. And a little of a doozy on that one. That's kind of like a medium or hard, like a leak code, but we're good for question number 4, home stretch for this video. We're going to be taking a look at stats from Shane McClanahan. So all these are going to deal with both these tables technically. So just as a nice solid heads up, I'm just going to copy this over here. And I'll just like put this towards the top so we can copy and paste this into our queries. But we're on the final stretch. And now just comment these out. All right, so for A, we're looking for average release speed, spin rate, strikeouts, and most popular zone. And we're actually only using last pitch race. So I lied. We're just going to use this table over here. And comment these ones out over here. And let's start working on this. So if we go back into this table, let's start copying down these columns. So release speed, we use just like that. So just put release speed. Okay, spin rate, let's look where that is at. I already know. So we have release spin rate. Release spin rate. Strikeouts. We go to events. I think there's a strikeouts. Look at that. Events, strikeouts. So I just put events equal strikeouts like that. Right. And that's going to be just a count or a case statement actually on that. So I'm going to just put like case because we want to release speed and release spin rate when it's not a strikeout. And most popular zone, which actually that might be a little more complicated than I thought. Zone. Yeah, that's gonna be a little bit more complicated. So let's start off with the easy stuff first, right? So if we just do a select average for release speed, right? Average release speed. We can just copy that again for spin rate. So average spin rate like that. And we're already getting to those columns. Next, let's just do a sum. Just do case when events equal strikeouts, then 1 else 0. And we're going to work on that zone a little bit later. I'm pretty sure it's going to be a little more complicated. We're going to end and do strikeouts. So if we just grab that, 1383, I am actually wrong. And the reason why I'm wrong is I forgot to put player name. So super easy to mess that up. And if you remember from earlier, I showed you guys where the name was on that other one. Well, we have player name here, which is last name, first name. So I'm just going to find where McClanahan is on here and copy this. So we're going to say where player name equals like that. And now we should get the correct 194, and that's correct. If we go to our Rays pitching stats for the season, we go over here to strikeouts. If I'm not blind. Oh, I am blind. I literally had it selected. 194. So that is correct. But now we need to figure out the zone. So zone's tough, right? Because there's no function, at least I'm aware of, that it's just going to do the most common. So what we have to do is, so we're going to select zone. We're going to count like this, right? And we're going to say where player name is this. So we got to think this through. So, and of course, we have to do a group by our zone because for some reason we forget this sometimes. All right. And if we do order by count descending, you can see zone 13 is the most popular. And if we go here, that's upper right on that side of things. And then 14 next popular. So 14 slightly outside, which is good. And then 5. Oof. But those two outside is good because you don't want to throw it right down the plate with number 5. But regardless, we need to show this data now over here. Now there is one way we could do this. We could join by this player ID. If we remember from earlier, I think it was just pitcher. So if we do pitcher like this and group by, let's see, pitcher and zone, you can see the pitcher ID is the same. So I'm going to do that. So what I'm going to try is join, and then I'm going to put this query in here. Well, I'm going to select top 1 on here. So it only shows the 1, right? Or I could do a max. I don't need to have this tops 1 because I could just do max for this count. But I'm just going to put zone num for this instead. I know I just completely changed my approach, but we're going to do the max of zone num up here. So that way these are still all aggregates. And we're going to join in this picture. So watch this. I'm going to throw this join right there, right? And I'm going to name this as zones, something like that, as, and we're going to say zones dot picture equals, and then I'm going to name this as LPR again. So we're going to name LPR dot picture, and under here now we're going to do max, and we're going to say zone num as zone, like this. I think, and instead of as, I should say we're going to put on there, just a typo. I think that's going to solve it. I think that's going to solve it. So let's see. Okay, order by. Yeah, we don't need the order by anymore because we did we're going to do the max, right? So we don't need that order by. And this is so ugly, man. Oh man, this is ugly. I'm going to throw that on there. Honestly, I might just another line. So you can see specifically how this works. Did not work. And the reason why it didn't work, as you can see, strikeouts now shows as 2522. So I have a bug in my code, and we're gonna have to really figure out what is going on that side of things. Maybe we do have to do a top one. I'm gonna try that, and I'm just gonna say zone num like this, order by count descending. That might work. All right, that did not work. So, and the reason is, I mean, we actually still might be able to put a max there. It still might work. Well, yes and no. All right. So, good thing and bad thing. Reason why this is still not working is we are grabbing the count of the zone num instead of the actual zone. So, let's put zone over here. And this should work this time. Well, once we label it, right? So we'll put zones dot zone. And this time it should work. Hey, there we go. All right, so what I'm doing is selecting the top row on here. So you can see how this query works, zone 13. We already have all this information over here. So we're joining it on that picture ID or the picture number. And then since we're only grabbing one thing, it doesn't really matter. We could do max or min. But that's so I don't have to put this group by down below. I'd rather just have this as an aggregate up here. And max of one row is always going to be that specific number. Kind of like a nice hint to know if you ever need to do that. And this one works. Definitely, it seems a lot easier of a question than it actually is. But this makes it a bit complicated. Let's go on to B. Top pitches for each infield position where the total pitches are over 5. So, and it says rank them essentially. So there's 4 infield positions. I'll show you guys this right now. We have 5, 6, 4, 3. So I'm just going to say like 5, 6, 4, 3. That's third. Short. Second, and then also first, and honestly, we can start off with a union. So select star from last pitch Rays, and we have a few different things we could use. So first, we need to take a look at the hit position. So hit location. So we have to have that equal to something. So hit location equals, and I forgot my where statement. So where hit location equals 5. Not, I'm going to say and. We're going to copy this player name is Shane McClanahan. So now this will just show us third base, everything on there. But now we need to group by our pitch name. So what we need to put over here is pitch name, all right? And we also need to do a count as input times hit. And then also I'm just gonna put like this, third, as position. We can filter everything a little bit later. And of course, like always, I'm gonna do our group bys. Not times hit, but and put our group by after our where. We actually don't need that group by with position. Some sloppy coding here, but all right. Now we just need to copy this for everything else. So I'm just going to union like that and copy that over. Union. Union. And then let's do 6 on that one. That's short. 4 is second. And 3 is first. Okay. Don't need all of this anymore over here. Let's run this. And all this is over here. Dandy. Great. Awesome. Now we need to filter out anything under 5. It's for times hit. So we have 1 for change up. Needs to be gone. And slider needs to be gone. Also, I think we should kind of order by times hit. Or order by position or something like that. So let's do a select star from. We'll put all of this in here. And close that. And then I'm going to say where times hit is greater than 4. Also, let's make this as A. And we have all of that right there. And it just says rank them. So we go to a rank function, or honestly right now, let's do order by times hit. Like that. And descending, of course. You can see 4-seam fastball, 24 times hit to second base, most common for Shane. Changeup hits to third base. Changeup also to shortstop, and a curveball to third. A lot of off speed there, and then next time 4-seam fastball to short. So a lot of up the middle with 4-seam fastballs and some off speed pitches. So kind of have understanding where this is at. Again, way more details that you could really build out if you wanted to. All right. 4C, show different balls and strikes as well as frequency when someone is on base. And if we go back over here, select star. What's considered when someone's on base? Well, we have these columns over here on third base, on 2B, and on 1B. So what I'll do, to be honest with you, is put where, let's make this a big or statement, and say on 3B is not null, or just copy all of that. Again, and we're going to do on 2B and also 1B. All right, so 2440, and we still need to show player name. This needs to be an and, because we need to have this and also this. So we're going to go way less than 2440 now. We're at 218 final outs when someone was on base. So now we need to select balls, strikes, and then counts. And then honestly, we just have to do group by balls and strikes. I think that should be it. Pretty easy. And we're going to say frequency. And you can see, like, we can do an order by. Just do count descending. 1-2 is pretty frequent when someone's on base. 2-2, and surprisingly 0-0 as well. But kind of makes sense if a better pitch is thrown, a batter would do that. 3-0 not as much. 2-0 not as much. 3-1 not as much, especially when it's in the batter's favor, which makes sense. The pitcher might be rattled. So a 2-0 count or a 3-0 count, you might be looking for a walk here. Might be looking for a walk here. Worst case is 3-2, but kind of just baseball theory. All right. Last one. Okay, so we're on our last question. So let's stay strong on this one. So we're just going to select star from Rays pitching like this. And it's saying what pitch caused the lowest launch speed. So what we could do first is just do a distinct pitch name. Pitch name. Not like that. Do it one more time. Tired, guys. It's been a long video. But now we need to also show where player name. So Shane McClanahan has 4 pitches. So not horrible there. All you really got to do now is say pitch name, and then what we're gonna do is average, and we're looking launch speed, which should have grabbed that column name. So we'll find that column real quick. And that column is launch speed like that. So launch speed times 1.00. And then it's not going to work because I need a group by pitch name. To that next line. Don't need this anymore. And then, let's see, this is launch speed. Okay. Order by like this. So what this is going to do is show it in ascending. And then all I have to do, top 1, run this query, and we are done. Now, again, highly recommend you rewrite these if you're going to really present them at work, because I don't like this syntax like this. I prefer things on different lines and kind of spaced out differently. But we just wrote, how many lines of code? Let's see, we're on 243 or so. And you guys learned some stuff in this project and have some stuff that you can apply to your own portfolio project. I'm going to jump off the screen now and we'll close out this video. Before I close out the video, just want to say this took me about 10 hours or so to produce. So if you're able to watch this all the way through, all I ask is for you to subscribe to the channel. It really helps it grow. And if you have any other friends in data analytics or want to teach them a little bit more about SQL, just share them this video. Hope that this was pretty helpful on that side of things as kind of like a portfolio project. I'm going to have a GitHub link down below so you guys can check it out. And we're going to be doing a lot more here on the channel. Anyways, if you're trying to jump and get a job in data analytics, I have a full interview series over here. I think we have like 15 or so videos. So be building up over time. But start checking those out and try to answer those questions as well.